Welcome to a journey through the heart of cosmic balance. In this video, we'll explore the concepts of cosmological self-equilibrium, CSE, and the cosmological equilibrium constant, CEC. These ideas propose that the universe and even the multiverse are not just random or chaotic, but are governed by deep principles of balance and self-regulation. Whether you're a science enthusiast, a philosopher, or just curious about how everything connects, this series will guide you from the foundations of equilibrium to the cutting edge of symbolic and mathematical representation. Let's begin by understanding what it means for the cosmos to be in equilibrium and why this matters for everything that exists. Cosmological self-equilibrium, or CSE, is the principle that the universe is an actively self-regulating system. Rather than being passive, the cosmos constantly adjusts itself, balancing expansive and contractive forces across all scales. Imagine gravity, dark energy, and quantum fluctuations all interacting in a cosmic dance, ensuring that the universe neither collapses nor flies apart uncontrollably. This dynamic balance is not static. It evolves as the universe changes, absorbing disturbances and correcting itself to maintain order. CSE suggests that the universe is like a living organism, always seeking harmony within itself. Cosmological Equilibrium Constant, or CEC, is a theoretical metric that quantifies the universe's balance. Think of it as a cosmic ratio, the amount of order versus disorder or balance versus imbalance at any given moment. When CEC equals 1, it means the universe is in perfect equilibrium. This constant is not just a number, it's a guiding principle that helps us understand how the universe maintains its structure, from the smallest particles to the largest galaxies. CEC is the output of the self-balancing process described by CSE. Make these ideas more intuitive, we use symbols. The asterisk stands for everything or anything, all possible states, entities, or realities across the multiverse. In contrast, the empty set symbol O* represents absolute nothingness, the primordial void from which all existence emerges. This duality for totality and O* for nothingness forms the backbone of our symbolic framework. It allows us to express the journey from nothing to everything and the constant interplay between existence and non-existence. The heart of CSE is a simple but profound equation. CSE asterisk equals some sign EX IX, right arrow 0 as X approaches asterisk. Here EX represents external expansive forces like entropy or cosmic inflation, while stands for internal contractive forces such as gravity or coherence. We sum over all X, meaning all points, entities, or states in existence. The net difference between expansion and contraction trends toward zero. This is the mathematical expression of universal balance. EC is defined as the ratio of balanced states to imbalanced states across everything. CEC equals sigma balanced states / sigma imbalanced states. When this ratio approaches 1, the system is in ideal equilibrium. In other words, the universe is always striving to keep this ratio as close to 1 as possible, ensuring that chaos and order are perfectly matched. This ratio can be applied not just to our universe, but to any system, including the multiverse. CSE and CEC are not just abstract ideas, they bridge the gap between philosophy and physics. Philosophically, they echo ancient ideas like yin and yang or the Taoist balance of opposites. Physically, they connect to modern cosmology, where the interplay of gravity and dark energy shapes the universe's fate. By uniting these perspectives, CSE and CEC offer a holistic view of reality, where science and metaphysics meet. But if our universe is just one of many, the multiverse theory suggests that countless universes exist, each with its own laws and constants. In this expanded view, both CSE and CEC apply not just within a single universe, but across the entire multiverse. Each universe seeks its own equilibrium, but there are also interuniversal interactions, gravitational, quantum, or otherwise, that influence the balance of the whole multiverse. The multiverse, the CEC, becomes a sum over all universes. C multi equals sigma CIFUIUJ, where CI is the CEC of the ITH universe and FUIUJ represents the interaction between universes. This could include gravitational pull, quantum entanglement, or other forms of influence. The multiversal CEC captures the collective balance, showing how universes can affect each other's equilibrium. How do universes interact? Two main possibilities are quantum entanglement and gravitational influence. Quantum entanglement could link universes at a fundamental level, allowing changes in one to affect another instantly. Gravitational forces, especially in higher dimensional models, might allow universes to pull on each other, altering their expansion or contraction. These interactions are modeled mathematically in the multiversal CEC equation. Symbolize cosmological equilibrium and its manifestation, we use omega. Here E stands for equilibrium and omega represents the totality of existence. Everything that exists is a manifestation of this equilibrium. Symbolically, for all X and asterisk is a subset of omega. This means every entity, event, or universe is an expression of the underlying cosmic balance. Mathematical heart of CSE is an integral. CSET equals integral EXT IXT dx over all X and asterisk. Here X represents any point or entity in existence and dx is an infinitesimal slice of reality. EXT and IXT are the expansive and contractive energies at each point in time. The goal is for the total sum to approach zero, meaning perfect balance. CEC is not just a static ratio. It can be expressed as a function of CSE. Specifically, sec t equals 1 / CSET plus epsilon, where epsilon is a small constant to avoid division by zero. As the net difference between expansion and contraction, CSE, approaches zero, CEC approaches infinity, indicating perfect equilibrium. This ties the dynamic process of balancing directly to the measurable constant of equilibrium. CEC can also be understood in terms of entropy. In this view, sec t equals s neg t slash s pos t, where s neg is negentropy order-forming processes and s pos is entropy disorder. This ratio shows that even in a universe full of chaos, there are always self-organizing processes at work, maintaining the overall balance. In the multiverse, each universe has its own balance and imbalance metrics. The multiversal CEC is the sum of all balanced states across universes divided by the sum of all imbalanced states. This treats the multiverse as a statistical ensemble, giving a collective measure of equilibrium that transcends individual universes. Let's clarify the symbols used throughout this framework. The asterisk means everything or anything. O stroke is absolute nothingness. EXT is expansive energy at point x and time TIXT is integrative energy. Means element of, so XX means belongs to set X means subset of and means for all. These notations help us express complex ideas with elegant simplicity. One profound idea is that CEC is always one. This means the cosmos maintains perfect dynamic balance at all times. No matter how chaotic or orderly things seem locally, the total sum of expansive and contractive forces always cancels out. This is like a cosmic seesaw that never tips no matter what happens. It's a foundational postulate that underpins the entire framework. Can we predict the next state of things if CEC is always one? Not exactly. CEC acts as a constraint, not a calculator. It ensures that whatever happens, the overall balance is preserved. Locally, systems may fluctuate, but globally, the cosmos compensates. This is similar to conservation laws in physics. Energy may move around, but the total remains constant. How can we use CEC equals 1 in deterministic modeling? By defining a local system and tracking its expansive and integrative energies, we can constrain the range of possible outcomes. If expansion exceeds integration, the system moves toward transformation. If integration dominates, it stabilizes. CEC doesn't predict exact outcomes, but it narrows the possibilities to those that fit within the equilibrium envelope. Predict future states more precisely, we need more data, both over time and across different conditions. By increasing the amount of training data, models can capture more patterns and generalize better. This is true whether we're modeling physical systems, economies, or even emotional states. The more data we have, the more accurately we can simulate the interplay of expansion and integration. Simulating a system with CEC1 involves modeling feedback loops. If expansive forces grow too large, integrative forces increase to absorb the excess and vice versa. This self-correcting mechanism ensures that the system never strays too far from equilibrium. Feedback loops are central to maintaining balance, whether in nature, society, or the cosmos. Stochastic elements introduce randomness or uncertainty into a system. Unlike deterministic models, where outcomes are fully predictable, stochastic models account for unpredictable fluctuations, like weather, stock prices, or quantum events. In CEC and CSE, stochastic noise represents real-world disturbances that challenge balance but don't break it. These random elements make simulations more realistic and dynamic. Simulate a CEC equals 1 system. Start by defining state variables for expansion and integration at every point in time. Use differential equations to model their interactions, discretize the system for computation, and introduce feedback loops. Add stochastic terms to reflect real-world unpredictability. Run the simulation over time, monitoring how the system maintains balance despite disturbances. After running the simulation, analyze the results by plotting expansion and integration over time. Look for cycles, tipping points, and periods of instability. Check that the overall balance is preserved even as local fluctuations occur. Adjust parameters and improve the model by increasing data and refining the feedback functions. Let's apply these ideas to a simple economic system. Expansive forces might include investment and innovation, while integrative forces are resource limits and regulations. By simulating how these interact over time, we can see how the system maintains equilibrium even as it faces shocks or changes. This approach can be extended to any complex system. Here's a quick reference for the symbols used. Means element of, means subset of, means for all is everything, O stroke is nothing, EXT is expansive energy, IXT is integrative energy, and DX is an infinitesimal element. These symbols make it easier to express complex relationships in a compact form. Symbol means subset of or equal to, indicating that all elements of one set are contained in another. The symbol is the universal quantifier, meaning for all or applies to every element. These are essential for expressing relationships like all things are manifestations of equilibrium, or for every point in existence, balance is maintained. Journey from absolute nothingness, O stroke, to everything is at the core of cosmological equilibrium. The universe and possibly the multiverse emerges from the void, manifesting as a dynamic interplay of expansive and integrative forces. This process is captured in the equations and symbols we've discussed, showing how balance arises from the most fundamental level. The multiversal framework, universes are not isolated. Each universe's equilibrium can influence others, leading to cosmic interdependence. This means that the fate of one universe may be tied to the balance of the whole multiverse. The CEC and CSE equations are extended to account for these interuniversal interactions, creating a grand tapestry of balance. Philosophical implications of CSE and CEC are profound. They suggest that existence is not random but guided by a universal drive toward balance. This echoes ancient wisdom and modern science alike, offering a unified view where chaos and order, creation and destruction are all part of a self-regulating whole. If you're inspired to share your own ideas about CSE and CEC, there are many ways to publish. Platforms like Zenodo, Medium, and RZiv allow anyone from scientists to enthusiasts to share their work with the world. You don't need formal credentials. Clarity, structure, and openness are what matter most. Your intuition and systems thinking are valuable contributions to the ongoing exploration of cosmic balance. Help visualize how CSE and CEC link. Imagine a diagram where the void O-stroke gives rise to everything, which is governed by the equilibrium principle omega. CSE describes the dynamic balancing process while CEC measures the degree of balance. In the multiverse, these principles extend outward, connecting all universes in a web of interdependence. Let's revisit the core CSE equation. CSE asterisk equals sum sin EX IX right arrow 0. In integral form, CSE t equals integral EX t IX t dx over all x and asterisk. This models the universe as a continuous feedback loop, where the divergence between expansion and contraction trends toward zero over time. In the multiverse, this becomes a sum over all universes, each contributing to the global balance. EC is defined as sec t equals bt ut, where bt is the measure of balance and ut is the measure of imbalance at time t in the ideal case. As t approaches infinity, CEC approaches 1. This ratio can also be expressed as a function of CSE, sec t equals 1 slash CSE t plus epsilon. In the multiverse, CEC is aggregated across all universes, giving a collective measure of equilibrium. CSE equation can be written as a differential equation. dCSE t slash dt equals integral EXT IXT dx for all x and asterisk. This models the rate of change of equilibrium over time. The objective is for CSE t to approach zero as t goes to infinity, representing a self-regulating universe. In thermodynamic terms, CEC can be expressed as the ratio of negentropy order-forming processes to entropy disorder. This highlights the interplay between chaos and order, showing that even in a universe full of randomness, there are always organizing forces at work. In the multiverse, feedback mechanisms operate across universes. If one universe becomes too chaotic, others may compensate, maintaining the overall balance. These feedback loops are modeled in the multiversal CEC equations, reflecting the interconnectedness of all realities. Imagine two universes with different dark energy densities. One expands rapidly, the other more slowly. Their interaction through gravity or quantum entanglement can cause each to adjust its expansion rate, maintaining the multiversal equilibrium. This scenario is modeled mathematically in the multiversal CEC framework. Make simulations more realistic. Stochastic elements, random fluctuations, are added to the equations. This reflects the unpredictability of real-world systems, from quantum events to social dynamics. By including stochastic noise, models can better capture the dynamic, ever-changing nature of equilibrium. Let's recap the key symbols. Means everything. O-stroke is nothing. EXT is expansion. IXT is integration. Is element of. Is subset of. Is for all. And dx is an infinitesimal element. These notations are the language of equilibrium, helping us express the deepest truths about the cosmos. CSE and CEC are more than theoretical constructs. They offer practical tools for understanding and modeling complex systems. Whether you're studying cosmology, economics, or personal growth, these principles can guide you in seeking balance, predicting change, and appreciating the interconnectedness of all things. You don't need to be a professional scientist to contribute to this field. Platforms like Zenodo, Medium, and RZiv welcome independent thinkers and enthusiasts. By sharing your ideas, you become part of a global conversation about the nature of existence and the laws that govern it. The exploration of cosmic equilibrium is an ongoing journey. As we gather more data, refine our models, and deepen our understanding, new insights will emerge. Whether you're inspired by intuition, science, or philosophy, your perspective adds value to this quest for universal balance. In summary, cosmological self-equilibrium and the cosmological equilibrium constant provide a unified framework for understanding the universe as a self-regulating, balanced system. From the void to the multiverse, from chaos to order, these principles reveal the hidden harmony that underlies all existence. Thank you for joining this exploration of cosmic balance. Ready to take the next step? Whether you want to publish your own theory, run simulations, or simply reflect on the nature of existence, remember that the quest for balance is open to all. Share your insights, ask questions, and keep exploring. The universe is waiting.